Hi everyone, I hope everyone is doing good. I think it's been a long since I make a video. There is a lot of works going on my study sites. Uh, that's why I can't make videos. Now I got some free time, so I started to record it. So today we are going to talk about longest consecutive sequence. Actually, once upon a time it was a hard problem few years back, and right now they decrease the complexity. So now let's understand what the question asked you to do was. So what the question asks you to do is they will just give you the unsorted array. You can see this is unsorted, right? It's in some random order. You have to find the longest consecutive sequence. So what do I mean by consecutive sequence? So if we take 1, 2, 3, 4, 5, dot, dot, dot. This is called as consecutive sequence. If we take 100, 101, 102, these are consecutive number, right? So that's what they're telling, longest consecutive sequence. If you just see in this example, what is the longest consecutive sequence? It will be 1, 2, 3, and 4. The longest consecutive sequence is 4 for this particular solution. I mean, for this given input, the answer is 4. That's what the question asks you to return. You have to return the longest consecutive element. I mean, sequence. That's it. We'll talk about the better solution and then optimal one. So I'll just quickly tell how brute force works. Okay. So what you can do is you can just start a pointer here and you can check whether one is there or not. Because the question asks you to find is longest consecutive sequence. So if you are at a point, you have to see for the next element is present or not. So just check 101 is present or not. No. So the longest is going to be 1 because 100 is valid, right? So that is going to be counted as the longest one. The length is 1. That's what this indicates. And just move the pointer 4. What I said, remember, it should be consecutive. So if you standing at 4 and sorry, if your value is 4, you have to see for 5. 5 is there? No. So and then longest is going to be the length is 1. So there's no need to update there. And just go to the 200 and find for 201 is there. Nope, 201 is not there. And again, the longest length is 1. So don't update anything. Now we just move to the 1. Now things started to change. For 1, you have to see looking for 2. Yeah, 2 is present. Now you find 2. Now you have to check for 3. Yeah, 3 is there. Now you find 3. You need to check for 4. Sorry, it should be here. 4 is there. And you have to check for 5. No, 5 is not there. So just count the length, the longest length right now. 1, 2, 3, 4. So just update our longest length to the 4. Okay, now just move the pointer to the next position. If you're standing at 3, what you have to do? You have to look for 4. Yeah, 4 is there. And when you're looking for, you have to find for 5. Now 5 is not there. So what is the longest sequence? 2. It is not greater than the 4, so no need to update it. So just move to the next pointer 2. So what you have to do, you have to look for 3. Yeah, 3 is there. And when you have 3, you have to look for 4. Yeah, 4 is there. And 5 is not there. So the longest length is 3. But it's not greater than this, so don't update it. Again, just move to 1. Again, this process will repeat. One more thing, this can contain duplicate value also. So you have to take care of that one. So the brute force time complexity will be big of n square because you need to iterate every other element and check whether it's there or not. Now let's talk about the better solution. I hope you guys understand brute force one. We don't need to waste time writing the pseudocode for it. So now let's talk about brute solution. And one more thing, this is also not a acceptable solution because the question asks you to write O of n time complexity algorithm. That's where optimal comes in. That's why the question was marked hard initially. Now it's converted to medium one. So we'll see better solution very quickly, and then we'll dive into the optimal one. Okay, so what is a better solution? So better solution will be like you just sort the given array. If you sort it, you will be like 1, 1, 1, 2, 3, 4, 100, 200, right? This is what you will get if you sort it. Now what you can do is you can easily count the longest subsequence because it is in ascending order, right? So what you can do is you can just stand over here and you have to check for 2 is there or not. Again, if there's duplicate, you can just skip it. though the elements are same, though just skip it. Now you will be standing at this position. You will look for 2. 2 is there. Of course, 2 is there. Now when you're at this position, you have to check 3. So 3 is there. Okay. And you look for 4. Yeah, 4 is there. Again, you look for 5. So 5 is not there. So this is the maximum length that could be formed starting from 1 till the 4. So what is the length? 4. Just make the answer to the 4. Now what you have to do is you have to start from here. So you are looking for 101. So 101 is not there. So the longest length is 1. Starting from 100, ending to 100. So the longest length is 1. So just move the pointer here. Again 200. Now you look for 201. Now we don't have 201 in our case. So the longest length is 1. So far longest length. And we just found this is our longest length. So we don't replace with this. This length is 1. This length is 1. But this length is 4. So which is the longest among it? 4, right? This is very simple solution. And one more thing, you can ask Magesh, how can I find whether 2 is there, 3 is there, 4 is there? For that, what we can do is we can just set entire thing and we can just ask whether 2 is there, 3 is there, 4 is there or not. Very simple with O of one linear time. Sorry, it's like constant time to check whether element is present or not. Now let's write the pseudocode for it. Sort the given input, and then what I said, you need to set the entire num, right? So num set, it's going to be set of nums. So in Python we do like this, and if in C we have something called, in C++ we have something called unordered map. You can use any of those things, similar logic. Just set the entire num. Set is like nothing but a collection of unique numbers. So again, we just eliminate duplicate. We'll just have the unique number in the set, and which can be look up in constant time. So you don't need n time to look up if something present or not. You can look up in single time. You can use hash map also here. It's your wish. You can use hash or set, anything. Now declare your max length as 1. As we see, every element is consecutive of length 1. So the max length is going to be 1. Now start the loop for I is 0 up until the end, and the current. So current is going to be 1. I mean the current sequence count. So now we'll check for duplicates. If nums of I is equal to nums of I plus 1. If it's same, just continue it. In this case, you can see this both are same, so we just continue. That's what this code does, this if case. So if it's not equal, we'll check the longest consecutive sequence. So for that, what you have to do is just have the temporary variable. So temporary variable is going to be nums of I, which is the current number, and we'll start the while loop. So while temp, this should be plus 1 because we are looking for the consecutive one. So if the pointer is here, we will look for 2, right? So 2 is going to be addition of 1 with this element, which is 2. That's what this temporary hold. While temp in num set, if it's there, what we will do, we'll just increment temp by 1. So temp plus is going to be 1. Now what will happen? From 2 it will become 3. So again we'll check whether 3 is in the nums or not. So if it's there, we just increment temp to 4. So again while we'll check 4 is there or not. It's there. And we need to increase the count also, right? I just forgot, like current plus equal to 1. We need to increase this also. At last, we'll just update the max. So max length is going to be max of max length comma current. So if it's greater, this will be updated to max length. And you can directly return max length. Very simple solution, right? Now, if you talk about the time complexity, it's going to be big of n log n, and we can count this like approximately. Let's say we cannot tell as approximate, so let's keep it as, again, at worst case it will be again n. Again it will give big of n, but let's neglect this thing. We don't need. If we see the complexity is going to be n log n, space is going to be O of n because we use set, right? This is the better solution. Now let's dive into the optimal one. And one more tip, it always good to visualize things before tackling them. Visualizing gives you a lot more thinking capability, a lot more ways to solve the problem. So now let's visualize this thing in our imaginary number line. Okay, so I just draw out a graph. So this is our imaginary graph line. Okay, I just remove duplicates. Okay, you just for visualizing purpose, I just remove duplicate from this number. I just put only the unique values. So just think what you can understand from this element. I mean from this graph. So this tells you that this group has max consecutive length of 4, and this group as 1, this group as 1. Let's call the group 1, group 2, group 3. So how do you finding that 1 is the starting of group and 100 is the starting of group 2 and 200 is the starting of group 3? How? Just think how. If you think carefully, 1 is the starting of this group because it doesn't have any previous number. If you look, what should come before 1? 0. But 0 is there? Nope. So we consider 1 is the starting element for this group 1. And if we see for 2, what is the previous number of 2? It's going to be 1. So 1 is there. So again, it's a part of this group. And if you come to 3, for 3, what do you need to have? Previous element 2. 2 is there. So 3 is also part of this group. Now you come to the 4. Ask for whether you have 3 or not. Answer yes. So this is one part of group. Again, there's no number in between, so I just skip it. Now come to the 100. Ask 100 whether you have 99 or not. So it tells that you don't have 99. So I am the starting of this group. We ask 200. 200, 199 is there or not? And he answers no. So 200 is the starting of this element. I mean this particular group. And we just go for next element. So there is no next element. So again, we just conclude this is 1, this is 1, this is 4 length. And the longest among us, this particular group. I hope you just understand. And we are just going to implement the similar logic in our code. So what we can do is, again, we just going to use the set concept here. And we'll use this logic. We ask that, right? And we use the similar logic here. We'll pick element and we'll ask whether you have the previous element or not. So if it doesn't have, which means this is the starting element. If not, this is some part of group. If you come to this 2 previous number is present. So which indicate that 2 is part of some group from the number line. That's what it tells, right? I hope you guys understand it. Now let's start writing pseudocode for it. Again, we need set to look up elements. Okay, to look up very fast, we need set, and we need to have the max length, right? So as I said, max length will be 1 because even a single element can make a group. If you say this is group 2, this is group 3, group 4, this is also a valid group, right? So at max you can have 1, you cannot have 0, right? You cannot have 0 element. So at max you can have 1. So just declare max length is going to be 1, and we can directly ask for num in nums. And what we can do is we can check this condition, right? Do you have any previous element or not? So if there's no previous element, then you are the starting element of this group. If num minus 1 not in num set, remember set, we have to set because the looking time is going to be constant. Sorry, yeah, it's a constant time. If it's there, then you are the starting elements. What I said, you need to look for next element, next element. Again, we use a similar concept. We use temp is going to be num plus 1 and current length. Current is going to be 1. Same logic while temp in num set, and we're just going to increment temp plus plus then current plus plus. At last, what we'll do is we just update the max length, and finally we just return the max length. Again, if you don't understand, we are just using the max method and we are just checking if already max length is greater or the current one is greater. If current one is greater, just update with it. If not, update with the existing sequence. That's what this method will do. And if you talk about the time complexity, this is the most optimal solution for this problem, which is O of n. Again, space is going to be O of n because of set. And again, the same thing, this doesn't count. At the worst case, it will be again O of n. It's only worst case. When the worst case happens, let's assume that you are given a list of 1 2. You can see every number is contiguous and the entire list is a consecutive sequence. At the time, you can get this what to tell, this time complexity, but it won't happen, don't worry. So we can just neglect it, and we can just have O of n as the best time complexity for this problem. And I hope you guys understand it. Now let's code this up. So as I mentioned, this question asks you to write a algorithm in O of n time. So now let's code our optimal solutions. As we discussed, we'll just declare num set of nums, and we'll have max length as 1, and we just return max length. Now what we'll do is we just iterate every item from the list, and we'll just check if num minus 1 not in num set, which means the current number is the starting of the category. If yes, then we'll have temporary will be num plus 1, and current length is going to be 1. We'll start the while loop, which will check temp and num set. If it there, then we have to look for next element, right? If 1 is there, we have to look for 2. 2 is there, we have to look for 3. That's what this does. This while loop, current again with plus 1. We have to increment the length, right? At last, we have to just update the max length is going to be max of max length itself and the current length. If current length is greater than the max length, this will be updated. And now let's run this. It passed all the test cases. Now let's submit this solution. Oh, we just forgot one base condition, which is if not nums. If there is no list, we need to return 0, right? So I just forgot this test base case. Actually, I forgot to see the constraint. It's my mistake. Okay, fine. Now let's submit this code. We got time limit exists. Let's see how we can fix this thing. Now let's go back to the editor once again. So why there is time limit exists? Because we are iterating to the nums array which contain duplicate. We just forgot to skip the duplicates. I just forgot it. It's a good part of learning. We just found while coding this up. What we can do is we can directly start iterating from the set, isn't it? Because set always as an unique element, it's not going to contain any duplicate. So we can directly start iterating from the num set. Directly we can start from here itself. We don't need to iterate from this given list or this example. We don't need to iterate from this. You can just iterate from the set of this is going to be 1 2 3 400 200. You can directly iterate from the set itself. You don't need to iterate from the nums. If you're doing so, make sure to skip it. That is a very lengthy process. For that, what you can do is we can directly iterate from the set itself. So now let's fix it, and we'll see whether our code is getting passed or not. So what I said, we'll just replace this with this. And now let's submit this. Yeah, our code passed successfully. It just accepted 81 test case with 51 MS, and we'll just analyze the time complexity. Yeah, it's always a linear time, and we did our best. And thanks for watching till this year, and we'll meet again in one more video. Until then, bye.